So now let's look at week 2.2 of Privacy and Security in Online Social Media course on NPTEL. So in this part, what I'm planning to cover is actually getting deeper into the topic called trust and credibility. So this is a slide that I will probably repeat over the course multiple times just to tell you where we are and where we're going. So we finished about overview of online social media. In the lab sessions, we have done Linux and Python. And you will actually get to see a little bit about Facebook, Twitter APIs. And now we'll actually look at the topic trust and credibility in detail. And later we'll cover some topics like privacy, social network analysis, e-crime, policing using online social media, and also identity resolution. So let's take a look at this graph. In this graph, just to help you read the graph, the x-axis is the number of hours after the Boston blast. The data is basically from the Boston blast that happened in the US. The x-axis is number of hours after the blast, and the y-axis is log of tweets. Basically, what does it show? It shows that at any given point in time, which is after the Boston blast, how much of tweets has been uploaded on Twitter. So there are three different colors in this graph, which is blue, green, and red. So the one which is in the red is actually the legitimate information, which you can call it as true information, which is posted on Twitter. Green, which is the rumor, which is information that is not legitimate or untrustworthy, non-credible content that has been posted, like the example, the crocodile example that I mentioned in earlier lecture. And the blue one, which is the sum of the rumor and the true information. So it clearly shows some messages, some implications from this graph. One, that is, the true information is actually coming later, is taking much more time than the rumors that started. In this example, there was in this event, the Boston blast, there was actually multiple posts which were related to this event, which was not actually legitimate. For example, one post which said that an 8-year-old kid was actually part of this Boston blast, which when there was no kid involved in the Boston blast. There was also another tweet which said that please RT this tweet, and we will actually pay $1 to Boston Marathon League, which also was not true. There are many examples like this, and these tweets got retweeted for more than thousands of times when Boston blast happened. This actually shows that there is multiple things one can actually look at it. One, how do you actually reduce the time in which the true information is coming, which is from, currently it's about 9 hours or so. How can you actually get this true information come onto the social network as early as possible? The other solution that you could also think of is how can you quickly reduce the false information that is going on social media to reduce. For example, in this case, the green one is actually peaking in couple of hours, and then it's actually higher than the true information. How can you actually quickly reduce the effect of or the flow or the information propagation of this particular rumor on social networks? So those are the two things that you could actually do. To do that, at least to reduce the effect of rumors, you need to actually understand what a rumor is. How can we actually identify these rumors on Twitter? That's what we basically look at in this section of this course, which is to identify ways by which I look at the tweets and identify whether they were legitimate or not. So now we look at misinformation on social media, which is some examples of the misinformation that was on Twitter. Here is one example which actually took a lot of effect in social media. When Ebola was going on, there was a lot of messages saying Ebola hoax, which caused deaths. And there was also discussion on the post about how salt water could be used to actually reduce Ebola and things like that. Boston Marathon, here is the specific tweet that I just now mentioned, which is RIP to the 8-year-old boy who died in Boston's explosion while running for the Sandy Hook kids. Right? That was not true at all. There's been many examples. I'm just going to give you some examples as motivation for this section of this course. Tweets of false shootouts caused panic in Mexico City. This was one of the incidents. and some tweets, some images that I actually talked about even in my first lecture, which is McDonald's Virginia Beach flood, the image on the left, where the image was actually a real image but was not taken during Virginia Beach flood, but it was actually taken many years before. And the Associated Press I've used in the past also. Here is a rumor on the right-hand bottom, which is London riots. Hearing reports that London Zoo was broken into and a large amount of animals have escaped. That's again a rumor. There's been many rumors like this in many of the events that has happened in the past. So what we're going to do is we're going to actually take one specific example. We'll actually do multiple examples over the course, over the entire course. Take up this event, take up an event, and look at actually the topic of misinformation in this case and other topics in future to study how we can actually analyze this data and make some inferences out of it in the context of trust and credibility. We'll do the similar way in the future also. For any topic, we'll take an event, we'll take some data that has been collected, do some analysis on the content, and make some inferences of the topic that we are interested in. In this case, we're going to take Hurricane Sandy. Hurricane Sandy happened in October 22nd and 31, 2012. And the idea for using an event is that you will be able to relate to it. And most of the times, analysis is done looking at a particular event. For example, now many people are interested in studying elections in the US. And I know there are people also interested in studying elections in India when it happens. So the damages that were totally worth for Hurricane Sandy was about 75 million. And the Hurricane Sandy basically hit the northeastern part of the US. There's been many fake images that was floating during the Hurricane Sandy. The one McDonald's have said before, and then the one in the middle has a shark in the water, and people were actually, there was panic among the public. And the right-hand top image, which is also from Hurricane Sandy, it's an image from a picture, and it was actually posted on Twitter saying that that's how it is looking in the US now. So particularly for Hurricane Sandy, if you see, there's been also effect of these fake information that was going on in Twitter. Hurricane Sandy brings storm of fake news and photos of New York. Man faces fallout for spreading fake false Sandy reports on Twitter. These are some incidences which is happening around the event Hurricane Sandy. So what we're going to look at is, again, some methodology, things that I will be talking about in this course is generic. I will try to actually emphasize on these methodologies so that you could take this methodology and apply it in any scenario that you are interested in, sometimes even in the homeworks and assignments that we will do as part of this course. Which is, first we start collecting data from Twitter about the Hurricane Sandy. And then some kind of data characterization, which is understanding how much of data has come, what data has come, and things like that. Feature generation, obtaining the ground truth, and then evaluating the results. This is a very high level, probably 30,000-40,000 feet high level view of what majority of the analysis on social media data would be going on. We ourselves in the course will look at different levels of view of this slide, which is later in the course we'll also look at something more detailed in terms of actually the whole process. The simple process is collect some data, do some characterization, understand some features, use those features to create a model, use that model to actually study the larger amount of data and evaluate the results. That's the general, if you've taken any machine learning or an information retrieval course, that's the kind of a simple process that people follow. So the data we are talking about, and this is one of the most exciting things that I feel about studying and researching in the area of online social media, is the size of the data that we're talking about. In this case, in the Hurricane Sandy thing, we're talking about 1,782,526 tweets that was collected while Hurricane Sandy that happened. Total unique users was about 1 million users, and tweets with URLs was about 620,000. Right? So that gives you a sense of how much of data was collected in terms of the Hurricane Sandy. So again, Please keep this as a template when you're doing some kinds of analysis of events. These kinds of analysis or these kinds of data description will help actually to look at the data, to understand what the data is, and in another sense, it will also help for somebody who's going to do it again. These kind of the same analysis or something similar, they would be able to actually take away some points from the data that you've described. So in this case, the map in the bottom also shows that where the tweets has come from. Of course, these tweets have geotagged information in them, and therefore we are able to actually mark it on the world map on where the tweet has come from. Of course, the big question is that how do you get the ground truth? Because now if you were to look at these tweets and say that which are fake, which are legitimate, you need to know what the fake tweets are. So there are multiple ways that people have tried, multiple techniques that people try, which is, we'll look at it some in the course and some probably I'll just mention it as we look at the slides. So in this particular Hurricane Sandy analysis that was done, the way it was done was the Guardian, which is actually a media house, they collected actually fake information. They manually annotated that these images are fake because they actually are a repository of a lot of content that gets generated on social media. They were able to actually annotate and produce a data set which says that in Hurricane Sandy these are the fake posts. Right? So reputable online source to filter fake and real images. Guardian collected and publicly distributed a list of fake and true images. What did they distribute? Tweets with fake images, 10,350 tweets. Users with fake images, 10,215. Tweets with real images and users with real images. Right? So using the reputable Guardian data, we actually looked at the data that was collected in this and then found that how many tweets had these posts, how many images that was posted were actually fake, and how many unique users and things like that. That's what was done. So when you do these kinds of analysis, when you generally look at online social media analysis, it's always best to look at analysis like this: who, when, where, what, why, and how. These kinds of analysis will actually help you to answer some interesting questions. Who posted it? When did they post it? Where did they post from? What did they post about? Why did they post and how did they post? So why and how are slightly trickier. It's hard to get. Why did the person post a rumor? It's hard to tell unless the person who posted itself actually confesses. How did they post is probably easier to, probably possible to get, which is to look at what device did they use, how did they post into the social media. Now let's look at more specifically the analysis on who, when, where, and what, and how and why. So in this graph, what I'm showing you is a network analysis, which is to show you who's the person who posted the tweet and how the information is getting diffused. The one on the left is a user who posted a content on this particular event. And when the user actually posts this content, obviously in Twitter there is going to be this retweets, favorites, and mentions of the user. So in this case, the red dot is the one of a particular user who posted this content, and the blue dots are the ones where the users have actually retweeted this content. So if you just look at this, the user's content is actually spreading among the other users in the network. So the one on the left is giving you the nth hour, the one on the right is giving you the n plus 1th hour. What's the difference here? So in the first one, there's only one user where his content is getting spread. Whereas in the one on the right, if you see that the post is actually diffused so heavily in the network within 1 hour. But there's also other observations that you can actually have. If you look at the number on the left of the user ID, so this basically the user ID is the one through which we can actually collect data from Twitter. It's a unique for every particular user. So the number on the left and then the numbers that are prominent in the right are actually very different. What does this show? This shows that the content that somebody starts, let's take if PK starts a content and his content gets diffused in the network, he may or may not be the one who's actually more popular after a given point in time. This basically shows that the information is, we can actually draw multiple inferences from this analysis, which is who's posting the content, how the information is getting diffused. For example, if you see C on the left, last 3 digits are 443, which is the prominent user. Whereas if you look at on the right, it's 199, the user which is in the center of the network. So that's one important analysis that you can do, inference that you can draw from these kind of analysis. This is called network analysis. We later in the course, we'll actually see some tools where you can actually draw these graphs with the data that you collect from Twitter or on Facebook. So in this graph, you can also see the user on the right-hand top corner, which is also more, which also has more number of retweets. There are some users which is bottom of the graph on the right, which is also who are also more. The tweets are getting more retweeted. So now let's look at a different kind of analysis from the data that we collect from Twitter. One of the problems that we can actually solve is to actually classify whether the post that is given to us or that comes from Twitter is actually fake or real. So in that context, we'll actually apply a technique called classification. Given that this is not a machine learning or an information retrieval class, we will not go into detail about what a classification is, what are the different techniques. I will just only look at the techniques that we apply with the data that we collect from Twitter. So if you look at this, the different kinds of features that we actually get from the posts that we get from Twitter are user features and tweet features. There are actually 3 kinds of content that you can actually look at from Twitter. One is the user profile, which is who am I? In my case, faculty at IIIT Delhi, got my PhD from Carnegie Mellon University and things like that. Second, the people whom I'm connected with, that's my network. My network would be faculty that are around the world, students that are around the world who are doing cybersecurity, people who study on social media and things like that. That's my network. Third is actually the content that I post itself. What am I talking about? I'm talking about my students, I'm talking about PSO or some course, I'm talking about some random things on social media, right? So those are the 3 broad categories of content that you can actually draw from the social media data, which is user profile, the content that somebody posts, and the third one being the network that somebody is connected to. So in this case, we are actually looking at the user features, which is more like the feed, which is more like the profile. Tweet features is the features from the tweet itself. Let me just go through a few of them that are listed in this slide, which is in terms of user features, number of friends somebody has, number of followers, follower-friend ratio. Follower-friend ratio is also one of the important things that we can actually use while making the decision on whether this user is actually a legitimate or a fake. For example, if somebody is a very popular user, the number of followings that they would have is actually much lower. That is, the people that PK would follow is actually lower than the number of people who would actually follow PK. So that ratio can be actually used to make a judgment on whether the network, whether the user is actually legitimate or not. Number of times listed. List is another feature in Twitter, where let's take, if I want to create a list of all the students who are taking PSOSM course, I'll create a list as PSOSM course on NPTEL, and I will actually add all the Twitter users onto this list. So that's called a list, and particularly this list has been used in different interesting ways. If I were to find the experts around the world on a particular topic, list could be actually one of the good ways to find out, which is if I were to create a list, or if somebody else creates a list on cybersecurity, and if they add PK onto it, there's high probability that that person believes that PK is actually an expert, and therefore he's adding him or her into that list. So number of times listed is one feature that you can use. Please go through the Twitter network to play around with the list and other features that I'm talking about. User has a URL, which is in my profile. I actually say that I am faculty at IIIT Delhi, and there's a URL called precog.iiitd.edu.in. If that URL is there, how good or bad is the user, you can actually use that feature to predict. User is a verified user. Verified user is another important feature that you could use, because of the total number of users on Twitter, there's only a few hundreds and thousands of users who are actually verified. Verified takes some process, and you have to have a large followers and things like that. So verified user can be a good feature to decide whether the user is a legitimate or a malicious user. Age of a user account, and this has been a feature that people have used in traditional internet security methodologies where they've actually used age of a website, age of a domain registration to actually find out whether the domain is legitimate or not. It's the same feature, which is PK created an account 5 years back. It's more legitimate, and if there's a PK account which creates, or if there's an Amitabh Bachchan account or a Rajinikanth account which is created recently, which may not be actually legitimate account. So that's the intuition behind using age of a user account. So next is tweet features. Let's just look at a little bit about tweet features itself. In tweet features, length of the tweet is a good information that you can actually use to find out whether the post is legitimate or not. So these are the features that you can use in general for making different analysis. I'm only using it for the problem of trust and credibility that we are talking about. So length of the tweet, number of words in the tweet, contains question mark, contains exclamation mark, number of question mark, number of exclamation marks, contains happy emoticon, contains sad emoticon, and things like that. So these are the different features that you can actually draw from tweets, and the features that I told earlier, which were actually user features. So five-fold cross-validation is a technique which is used to make sure that the confidence on the classification accuracy that we are building is higher. That's the reason why we use actually five-fold cross-validation. And there are many other techniques. I'm not going to go into details of different other techniques that are available. Now let's look at the results from the classification that we did. So as I said, F1 is a user feature, F2 is a tweet features, and in classification techniques, we can actually use F1, F2 separately and also create the features of F1 plus F2. The two techniques that were applied, one is naive Bayes, which actually uses Bayes' theorem to find out whether a particular post is legitimate or fake, and which features actually influence a lot in making the decision. And there's also another technique, which is a graph-based technique, which is decision tree, where all the outcomes and the probabilities are actually laid down as in the form of a graph. And it's a very popular machine learning technique, which is applied to make decisions. And in this particular case, decision tree actually seemed to have worked better, particularly while using the tweet features, where the efficiency was about 97.65% in predicting whether the post is fake or real. And the tweet features F2 seems to have played well in both naives and in decision tree, whereas user features did not play that much well in making the decision. Now let's look at an event, Boston Blast. Again, we'll use this technique of looking at events. Through the events, I'll actually inject a lot of techniques that we will actually study in this class, and terminologies also that we'll see. It's a twin blast that happened in 2013 in April. And 3 people were killed and 264 were injured. First image that came on Twitter was within 4 minutes. It's basically a Boston marathon that was going on, and the blast at the finish line was the event that happened. And there were actually multiple fake tweets. Here I'm just showing you 2 popular fake tweets that were actually floating around on Twitter. The first one, I've showed this tweet in the past also, RIP to the 8-year-old boy who died in Boston explosions while running for the Sandy Hook kids. There was no kid who participated in the marathon. And another post at the bottom, you see for every retweet we receive, we will donate $1 to the Boston Marathon victims. And it is posted by an account called _Boston Marathon, something that you want to keep in mind, which was not a legitimate account. And this post was retweeted for about 50,000 times. And these are the 2 popular tweets that were floating around during the event, which were fake. Data that was collected during this event was actually about 7.8 million tweets that were collected, 3.6 million users posted this tweet. And if you look at the advantage of actually working in the space of online social media, is actually these large numbers that we look at. Tweets with URLs is about 3.4 million, 62,000 people post had geotagged, and about 1% is what Twitter claims that the tweets that are posted on Twitter are geotagged. Tweets about 4.4 million, replies 260,000, and the timeline of the blast, first tweet, first image, and last tweet. All of that is captured in this slide. And I'm showing it to you because when you actually present, analyze events, analyze a particular topic, and again, studying this analyzing event is only one way, but we are actually, you can actually adapt this to studying any topic. For example, in this case, how do we collect the data? We take hashtag Boston Marathon, which was actually trending, and start collecting the tweets which has hashtag Boston Marathon. Look at other words that are in the post that has hashtag Boston Marathon and use those keywords to start collecting other tweets, like a query expansion concept, and thereby we collect the post from Twitter. And this methodology can be used for collecting any data. Data could be hashtag MacBook Pro, hashtag Apple, hashtag India, and things like that. Not necessarily it has to be hashtag, also it could be any other words. Here I'm actually showing you a graph which is on the x-axis is the hours after the blast and the y-axis is number of tweets. So the crux of this slide is to show you that the spikes that happen on social media is actually very, very connected or correlated to the events that happen in real world. For example, here the first spike that happened is 1 hour after the blast. Then there was a spike in Twitter tweets, which is pictures of suspects released, and manhunt is over. So if you really look at it, that's the way that the content that gets generated on social media is actually behaving. And we've tried looking at these kind of graphs for many, many events, and it looks very similar. Very similar in terms of actually spike being correlated to the real world incident or an event that happens. And here is another slide which actually shows you the geotag coordinates of the tweets that were posted on Twitter, particularly for this Boston Marathon blast. And every dot in this slide shows you the tweets that has come from that particular location. Understandably, the posts have come mostly from the US. So now in this event of Boston Marathon, a technique that was applied for finding out whether a post is actually rumor or true or fake, first tagged most viral 20 tweet content, which is whether it's a rumor, fake, true or generic. 6 rumors were actually collected from the posts that were talking about Boston Marathon. And 7 true news was collected, which is doctor's bomb contained pellets, shrapnel and nails that hit victims, Boston Marathon, hashtag NBC6. So those kind of tweets were collected, which is about true news that was getting posted during the Boston Marathon. And 6 rumors were collected and 7 generic posts that had pray for Boston. Pray for Boston also was actually trending during that time. So essentially what we were trying to do is we were trying to study, look at the rumors that were posted, true news that were coming, and some generic information, generic posts that happened during in the Boston Marathon event. This kind of gives you a generic sense of what are the different posts that happen in an event like this. And rumors about 29% were actually retweeted, true news about 20% were retweeted, and 51% of the generic content was actually retweeted. So here's another view of the data, which is to show you the fake content user profile. So every time such event happens, incidentally, what happens is many of the fake user profiles get generated during the event. Fake accounts get generated to actually use the event to propagate malicious content. So in this example, I'm showing you account 1, account 2, account 3, account 4. Different accounts were actually created. You will actually see that the accounts has number of followers, which is account 4 being very high, account 1 being very low. So this is, and if you see the account 1, which was actually created on March 24, 2013, which was posting fake content. Account 2, which was created October 15th, 2013, very close to the Boston Marathon, and account 3, February 2013, and account 4, 2008. Total number of statuses is the updates that they did, and number of fake tweets that they posted is 2, 2, 1, and 1 respectively. And if you see, some of the accounts get actually suspended, and these suspensions happen because people report about this handle to Twitter, there are multiple ways to actually take down a particular account. One is large number of people actually report a particular handle to Twitter and it gets suspended. And there are, through government processes, you can actually apply for suspending an account. If you see the last column, it's interesting that some of the user handles which are posting fake content on events like Boston Marathon actually are active even when we were actually collecting the data. This just shows you that fake content are propagated by fake user handles, and these user handles is created just after the event, or just before the event, just after the event happens. So now let's look at a different view of the analysis, which is tweet source analysis. This gives you an insight about what devices do people use while posting the content. 76% of the posts that was identified as fake was posted through mobile, versus 64 in true and 51 in general content that were posted. This insight about what device is being used while posting this content can be very useful in making decisions. For example, if you want to do a targeted advertisement, what kind of devices are being used can be very useful in making the decision. So this information is available in the JSON that you collect from Twitter for every tweet. So you can use that to make this judgment. So if you look at the number of accounts that were created during this event, it was about 32,000 new Twitter accounts were created during this event, which were actually talking about this particular event. Out of this, 19% were deleted or suspended by Twitter, which again could have happened for multiple reasons, and 19% of accounts that were created were actually suspended. So this is a graph to show you hours after the blast, x-axis being the hours after the blast, and y-axis being number of suspended accounts that were created, which is just to show you that the number of accounts that gets created immediately after the account is also high. In addition to that, number of accounts getting deleted is also high. The fake or malicious accounts that were suspended, that were created and suspended, were very high immediately after the event, and after the event, it kind of reduces a little bit. Let's look at the connection between the fake accounts itself. So again, just keep in mind the kinds of analysis that we're doing is who, when, where, and what, why, and how. So again, the one insight into the analysis is this: how are the people who are posting this content, which is fake, are connected? So one insight is that they're actually pretty closed. And this is not only in this domain, you can actually see these kind of analysis in many other domains also. For example, in classical security problem like phishing, the number of groups, number of accounts, number of sets of people who do this is actually very small. And they're all very well connected. Similar kind of inferences is derived from this particular analysis also, where for the Boston Marathon, if you look at people, the node here is the user, and the edge between the nodes are the action of retweet, following, and followers. So therefore, there's a closed community that is actually operating in terms of posting this fake content. So while doing this, you could actually think about, so earlier, I think in week 1, I actually showed you some very high level slide about how machine learning and about how these kind of approaches of identifying fake and legitimate can be done. This is just a slightly zoomed in view of the same slide, which is to show you that the data is coming from Twitter through streaming API. I assume everybody knows now what a streaming API is, which is to collect data from the social networks. Tweets are dumped onto the database. Human annotation, which we saw earlier also, in terms of annotating the post. Even now we saw about fake, generic, and true posts. Those are all sometimes human annotated, sometimes you could actually use some simple techniques to do the annotation. One of the important things that you also want to do when these annotations are done are inter-annotator agreement, which is if I say something that's legitimate and if you say something that's legitimate, then probably more people saying a post is legitimate, then the post must be legitimate. That's the kind of intuition that the Cronbach's alpha, which is a value that you will get for finding out inter-annotator agreement. And if the Cronbach's alpha is generally about 0.7, it's actually understood that the data you can have more confidence in the inferences that you're drawing from this particular data. Cronbach's alpha is the value that you will calculate while finding out inter-annotator agreement. And so, as we discussed earlier, also feature extraction. Feature extraction is a technique by which we looked at F1, F2, and those things. You will use that to find a model. Here, I'll just describe a little bit in the later slides about what model can be generated. And you use that to find out whether this particular post is legitimate or not, and then you can actually show that to the user also. That's the architecture that is presented here. Again, it's a very simple machine learning approach, which is take the posts, use the post, do some feature extraction, use the feature extraction to create a model, use the model to actually predict whether the post is legitimate or not. So in using this architecture, instead of just doing one or two events, multiple events data were collected and used to find out whether a particular technology can be built in identifying whether this post is legitimate or not. And here are the events: UK riots, Libya crisis, earthquake in Virginia, US downgrading. There are many events. Data were collected, and as I said before, the third column here, which is trending topics, these were the topics that were trending using which the data was collected. The column 2 shows you the number of tweets. Again, a large number of data was used while doing this analysis. As discussed before, one of the methods to find out whether a particular post is legitimate or not, annotation was done. There are multiple ways to do this annotation. Also, you could get 3 of your friends to sit down together and tell you whether every post is legitimate or fake. You could do it through Mechanical Turk. Mechanical Turk is a crowdsourced mechanism by which you could actually show these posts in the platform of Mechanical Turk. The Turkers will look at it. Turkers are basically people all around the world who are doing this task for small money. Step 1, in this case, contains information about the tweet. A post is shown to the user, and then the user actually decides on one of these 4 categories, which is contains information, is related to the event, not related to the event, skip. If in the step 1 it says that contains, the user decides that there is information in this post, then the user is asked about definitely credible, seems credible, definitely incredible, and skip tweet. Again, here I'm only going through the methodology, which is post is taken, it's annotated. You could annotate it for any particular topic that you want to study. In this case, it's credibility, but you could also think about it whether this post has a phishing URL or not, if this post is talking about a particular event or not, this post is sensitive or not. You could do many things in terms of annotations and the topics that you are interested in studying from the post that is being collected. So from step 1, you take the data and then you ask the users to classify it as definitely credible, seems credible, definitely incredible, and if there's nothing, the user cannot make a decision, skip the tweet. And that's why I said about Cronbach's alpha, which is something I'll emphasize here. Each tweet should be annotated by at least 3 people, because that will give you more confidence in the data. And when you do this, it's called inter-annotator agreement or Cronbach's alpha. You should calculate that, and if it's more than about 0.7, it's generally accepted that the data has more value or confidence in it. 30% of the tweets provide information, which is in the step 1. Users agreed that 30% of the tweets that were shown to them had information. Only 17% had credible information, and 14% was spam. Feature sets, since we discussed just now some time back about different features, F1 and F2 in that slide here, message-based features and source-based features, which is, again, if you look at it, I told you about features from the posts, which is message-based features, so features from the profile, which is source-based features. Using these features, we used a metric called NDCG, which is Normalized Discounted Cumulative Gain. It is nothing but a way by which you can actually measure the efficiency of the search. NDCG has been commonly used in finding how good a search engine is performing. In this case, we are using it to find out what is the quality of the classification that we make, whether it is legitimate or fake, in this metric called NDCG. So here is a graph for looking at the content from the tweets that we collected, looking at the posts that we collected: recency, tweet, user, Twitter plus user. These are the features that we used, if you remember, to find out whether a post is legitimate or not. We're drawing a graph of n, which is on the x-axis, and NDCG value, which is on the y-axis. You can clearly see that the tweet plus user, which is at the top of the graph, doing well in terms of the NDCG values. This basically helps to understand that what you post and who you are good features to make judgment on whether the content is legitimate or not. That's the kind of inferences that you should be chasing while you are analyzing the content from social media, which helps in some actionable information also. For example, here, what you post and who you are helps to find out whether the post is credible or not, which helps in making a lot of decisions. Using this understanding of what feature works and what features don't work, and what feature actually influences in finding out whether a post is credible or not, TweetCred, a Chrome browser extension, was built, and this extension helps you to identify whether this particular post is credible or not. I'll just show you a live demo of the TweetCred extension, and then I'll walk you through what is available in the Chrome extension. What I'm showing you here is the TweetCred browser plugin, Chrome browser plugin, which actually helps you in making a decision whether a particular tweet is credible or not. It just gives you, it basically uses all the features that we discussed until now, where it is being bundled into this Chrome extension. So look at this tweet. If you go to twitter.com in your timeline, this information about whether a post is how credible is it will not be there. This is coming from TweetCred. If you look at this, it actually gives you a value of 3 on 7. It is calculating the value of credibility on a scale of 1 to 7. And in this case, it is showing that this is my timeline. In this case, it is showing that this post is 3 on 7, this post is 5 on 7, and values like that. So it is going to work for all the posts that are in your timeline. It is going to work for what is in your search. It's going to work for post and DM and things like that. So let's look at the values that it is presenting also. So if you see here, it is actually showing you a value of 3 on 7, and then when I hover it, it actually gives me an information called credibility medium 3 on 7. Do you agree? So this is the way, if you remember the machine learning model that we built using the feature, you take that model, and whenever we get feedback like this, we can actually go and update that model to make it more efficient. So in this case, you could actually say that, no, I actually agree with the value of 3 on 7. It gives you a message saying thank you for the feedback. In this case, let's take, if I were to say that the value, I don't agree with the value, then it actually asks me, okay, what do you agree with? So I say, no, this is actually more credible. It should be actually 7. Then it says, okay, thank you for the feedback. So what it basically does is it is capturing these details from you, and it is going to make use of it when we end up updating the model that was built at the back end for the TweetCred. This information can be used in making the judgment. So that's the Chrome browser extension of TweetCred, which basically takes the features in real time and makes the judgments and presents it to the user with the values of 1 to 7. So you may remember the features that we discussed in this lecture. But unfortunately, all features cannot be actually used while doing it in real time. For example, finding out all the followers that you have and using some scores on the followers is actually hard. So here are the 45 features that were actually used while doing the real-time analysis itself. Specifically, I wanted to highlight on the presence of swear words, presence of negative emotion words, presence of positive emotion words, Web of Trust score, which is WOT score for the URL, and ratio of likes and dislikes for the YouTube video, which has links to the YouTube, right? So these are the features that we did not discuss before, so I kind of thought we'll highlight them when I'm presenting this slide. So these features were used in building the TweetCred demo that I showed you. Of course, the common question is, what are the top 10 features that actually makes the decision, or which influences in identifying whether a post is credible or not more effectively? It's the number of characters in the tweet, unique characters in the tweet, number of words in the tweet, user has location in the profile, number of retweets, age of tweet, tweet contains URL, tweet contains via, which is through how the post was done, statuses, followers, friends, and followers. Those are the top 10 features of from Twitter, which can be actually used to make a judgment on whether a post is legitimate or not. Please keep in mind, this is only for Twitter. The features that you will look for in Facebook, the features that you may look for in Instagram, in other social network may be very different. Here is just a slide to show you how the implementation for the TweetCred was done, which is a Chrome browser extension. There is a post that is on your timeline. It takes the post, fetches data using Twitter API, which is the architecture that I showed you earlier, where feature extractions are done, and then a model which is built. Tweet is taken through the API, feature extracted, the credibility score is computed with the techniques that we discussed until now, and the values are sent back to the API again. Then the tweet ID and the credibility value comes back. It's presented in your timeline saying this value is actually 3 on 7, the demo that I showed you. It's a simple Chrome extension that was built to show these values. So users can also give feedback to the system, and as I showed in the demo, TweetCred actually asks user to say agree or disagree with the values that is presented. If you agree, that's okay. If you don't agree, please provide the information. Please provide the value that it should be. What do you think it should be? That's what is presented in the top left, which is when you agree. Bottom right is actually saying if you disagree. Different types of users that can be foreseen using TweetCred type of tools. Again, please remember, TweetCred is only one example that I'm presenting here. There are many other tools that one could think of while analyzing social media content and information presented to the user. In this case, emergency responders, firefighters, journalists, news media, and general users also have started using tools like this. Let's do a quick summary of week 2. When we started, we actually looked at APIs, programming interfaces, and you also have a tutorial for Facebook in this week. Then we looked at very briefly what Python programming language is, MySQL, MongoDB, PHPMyAdmin, and when you collect the data, you're going to actually hit the rate limits. Please remember that there is always going to be rate limits when you're collecting the data from these social media services. And we talked a little bit about the format in which the social media services store the data, which is JSON, and when you collect the data, you're going to get JSONs, which you'll have to analyze through your scripts. And Facebook stores all the data in terms of a graph. We looked at that briefly. Then we started delving deeper into trust and credibility as a focus area. We looked at these concepts of trust and credibility through events. Meaning Boston Marathon was one of the events, Hurricane Sandy is another event that we looked at. We looked at these events. Through these events, I was trying to tell you how data is being analyzed, what kind of techniques are being applied on this data. We looked at classification as one of the major techniques that is used while deciding whether a post is credible or not. And during this analysis, I also told you about who, when, where, and what, why, and how are the basic questions that you can actually analyze using the social media content. And specifically, we also looked at some social network analysis techniques and words. So that's for week 2. Hopefully, you will go through the content. And if you have any questions, please feel free to ask in the forum. We'll be happy to actually answer them.